function generator. This is also known as signal generator because it provides the required input signal for our electronic circuits. The various parts of this function generator is first the function selection section. Here you can select it as a sine wave. If you want a triangle wave, you can use this knob, and for a square wave you can use this knob. This is in fact an attenuation knob, that is 50% attenuation. If you press this knob, then it would mean that whatever signal you are getting, it will be compressed or attenuated to 50%. So always better see to it that this knob is in a released position so that you have not applied any attenuation without your knowledge. So this is the function selection region. Now coming to the frequency selection, this is the selection knob for various frequency range. This is a knob for adjusting the frequency in a coarse manner and fine manner within this selected range. That is, if I use this 1K knob, then it would mean that I can get a frequency up to maximum of 1K here. So in order to adjust the frequency in the range of 1K, you can use this coarse frequency select knob, and this can be used for fine selection of a correct required frequency. So if I use this 10K frequency range, then it means that I can get frequency up to 10K in this situation. And to vary it in that range of 10K, you can use this coarse adjustment knob as well as this fine adjustment knob. So this section is connected with frequency. You can have frequency less than 1 Hertz also here. You can go up to 100 kilohertz and up to 1 megahertz. So that is a maximum range of frequency you can expect from this function generator. Now coming to the voltage section, this is the range of voltage that you can get. So if the knob is in 2 volt, it means that we can get up to a maximum of 2 volt. And within that 2 volt, you can use this knob to adjust the voltage. Now, to go for the higher voltage, you can use this knob to 20 volt position. So you will get a maximum of 20 volt here. So within that range, you can use this voltage adjust knob. Now coming to this offset. This is DC offset. That is, you really don't need it frequently unless you want to set an initial DC level for the signal, or if you want to apply a DC correction for the signal, you use this DC offset. So usually we keep this in the off position. See to it that you keep it in the off position once it is calibrated. So that is the DC offset. You really don't have to adjust it if situations are fine. Then comes the output knob. Here you are provided with 2 output knobs. It's BNC connectors. So you can see this is 600 ohm and this is 50 ohm output knobs. This resistance refers to the internal resistance of this function generator. That is, any source will, this is acting as a source. So any source will have its own internal resistance. If you take the output from this knob, it means that the internal resistance of this circuit will be 600 ohms. If you take output from 50 ohms, it means the internal resistance of this function generator will then be 50 ohms. Usually for our simple electronic experiments, we need a low resistance, internal resistance. So we prefer to use the 50 ohm knob for the output. Now coming to this display unit. This display unit is meant for frequency display as well as for voltage display. So the same unit can be used for voltage display and frequency with the help of this knob, read VP. So you can press this and release it. Then it is meant for reading two different parameters. Now let us switch on this power supply. You can see that there is a negative sign over here, minus sign. It indicates that it is at present displaying the frequency. So if I press this button, that negative sign is gone, and it means that for the present it is measuring the voltage. So that is how you have to interpret it. When this is in the pressed position, you are reading the VP, that is the peak voltage of the signal. When you release it, you will have a negative sign, and it is not in fact a negative sign but just an indicator, and it refers to the reading of frequency. So once the power is switched on, we can select the required range of frequency. If it is 1K, press this. If you want something in between 1K and 10K, use this knob. If you want something between 10K and 100K, you use this knob. So select the frequency, select the nature of the shape of the wave, whether you want triangle wave, square wave or sine wave. You select it. Now I have selected sine wave and a frequency in the range 1 kilohertz. So within this 1 kilohertz, I can change the frequency with this coarse knob. I can also use the fine knob for fine adjustment. So I'm adjusting it to a frequency of say 1 kilohertz. The range is 1 kilo. The maximum I read is 1 kilo. So this is a coarse adjustment for frequency. This is the fine adjustment. Now I will select the voltage. I'm selecting the range. I'm selecting it in 2 volt range. So I can expect a voltage of maximum 2 volt. So if I want to read it, I will press this knob to show the peak voltage VP. So now it is 0.884 volt. It is a peak value of the signal. That is, if there is a sine wave, from the reference point to the top, it is a peak voltage. We will see it in CRO. So now I'll adjust it and make the voltage 1 volt. So once again we'll check. This is 1 volt peak voltage and this is 1 kilohertz frequency. Now if I only want 20 millivolt, what I'll do is put this in the range of 0.2 volt so that the maximum possible voltage in this knob is 0.2 volt or 200 millivolt. So I will reduce it. If I want it only in the position 20 millivolt, I will use this voltage knob and reduce it to 20 millivolt. 10 millivolt VP. So upward 10 millivolt and downward 10 millivolt, peak to peak would be 20 millivolt. This is a minimum voltage which is possible from this signal generator. Now let us apply this signal to the CRO and observe this signal. So hope you are familiar with CRO. There are 2 channels for CRO. So we will use this first channel. Select the first channel over here, release the second channel and select the first channel. And use this card, first channel card, to observe the signal. So please ensure that both the channels are initially in the ground position, and then switch on the CRO power so that you can see the reference line over here. With vertical edges, you can adjust it vertically and place it in the central position. Now we will connect the signal generator to the CRO. This is the BNC connector terminals of the signal generator. This is the BNC connector terminals of the CRO. So positive of the signal generator is connected to the BNC end positive of the CRO, and negative end of the BNC is from the signal generator is connected to the negative terminal of the CRO. We have set the signal voltage as 10 millivolt and frequency as 1 kilohertz. Now we will observe it in the CRO. The connections are made, power is on. So I would like to release it from the ground. Before that, ensure that this volt per division is in a high position or high value so that it is safe for the CRO. Now release it. Come down to observe your small signal of 10 millivolt. Now it is 50, now it is 20, now it is 10 millivolt. So adjust the position. So it is 10 millivolt per division. Here it is written 10 millivolt per 1 centimeter division. So it is from this reference, it will go 10 millimeter up 1 division and 10 millimeter down from the reference line. So releasing from the ground. So this is a signal. Peak to peak it would be 20 millivolt. You can have a better view now from the central reference line, 1 division up, 1 division down. So it is, now the knob is in 10 millivolt, millivolt per division. So it is 1 division into 10 millivolt, that is 10 millivolt. So peak to peak it would be 20 millivolt. Please ensure that all the knobs are in the calibration position initially. Now let us focus on the frequency or times per division knob of the CRO. This is in 1 millisecond range. This is a knob head. It is in 1 millisecond range. So it means that on the x-axis where you read the time, 1 division, 1 square centimeter or 1 division, that is this point to this point, it is 1 division. So 1 division into the multiplier 1 millisecond per division will give you the time period as 1 millisecond. So that it means the frequency of the signal would be 1 by f, that is 1 kilohertz. So what we have set is 1 kilohertz signal of 20 millivolt peak to peak. Now if I want, I can change the frequency to 10 kilohertz. I will read the frequency now. It reads 10 kilohertz. Let me see how it looks like in the CRO. To observe it well, I will change the times per division. So now this is the signal. Now it's a very clear signal. I have to read the times per division at present. It is 0.1 millisecond into 1 division. So time period is 0.1 millisecond and it would mean a frequency 1 by f is equal to 10 kilohertz. Now let's see how to change the voltage. Let me keep in 1 volt. So I'll change the range to 2 volt. I would like to read the display of voltage. Use the voltage knob to increase the voltage to say 1 volt. Before doing this, and ensure that the CRO is grounded. Whenever you change your signal, please ensure that the CRO is grounded first. So I'm increasing the voltage up to 1 volt. Peak value 1 volt. So peak to peak would be 2 volt. So as I have changed the signal, I had grounded the CRO. Now I would release the CRO. The voltage knob should be kept in a higher value. So I will keep it in 1 volt range now. If you would like to observe it in a magnified manner, 1 volt per division is the range now. So here from the reference line, which I can put it as ground, relays it. So 1 volt up and 1 volt down. So 2 volt peak to peak is the signal now. So this is a 1 volt signal, 10 kilohertz frequency, because the frequency knob is 0.1 millisecond range. Now in this signal generator, function generator, let us change the function from sine wave to triangle wave and then to square wave and observe it in the CRO. So this is a triangle wave. This was the sine wave. This is the triangle wave. This is the square wave. Here the square wave, you can see that the vertical portion is not really visible because of the fast change in display with respect to time, because x-axis is the time axis and y-axis is the voltage axis. So this is one square wave. The intensity I can increase a bit, but due to this external light, this vertical line is not clearly visible. So this is this triangle wave, this is sine wave, and this is square wave. So once again, to sum up the function generator, these keys are functions: sine, triangle, square. This is attenuation. You don't have to use it unnecessarily. This is a range selection for frequency. This is a knob selection for frequency of the signal. This is the voltage section, range selection, adjustment knob of the voltage, range selection of frequency, adjustment knob of frequency, range selection of voltage, adjustment knob of voltage. This is a DC offset. This key is meant for the change of display from frequency to peak voltage. So when it is pressed, it reads VP, the peak voltage. So that is all. These are the two output terminals available for the signal generator. This is the power switch. Thank you.